The universe just keeps finding ways to remind us how powerful it can be. It's pretty awe-inspiring.
It really is.
And today we're diving into something that kind of redefines mind-boggling. A whole new class of cosmic explosion has just been identified.
Exactly. So in this deep dive, we're going to unpack these things called extreme nuclear transients, or ENTs.
The ENTs, okay.
Yeah, and we'll explore what they might tell us about supermassive black holes and maybe even how galaxies get shaped. We're drawing on some new research here, reported in Science News.
Right, from Science Advances. Okay, so extreme nuclear transients. Let's break that down. What makes these explosions so, extreme compared to, say, a supernova?
Well, what's really fascinating here is just the sheer power involved and, crucially, how long they last. They're described as very bright and very long-lived.
Long-lived, okay. How long are we talking?
So get this. Each one of these ENTs, it releases more energy in about a year.
A year?
Yeah, more energy in roughly a year than our sun will produce in its entire 10 billion year lifetime.
Wow. That's almost impossible to picture.
It really is. And they take over 100 days just to reach their peak brightness.
So shining at full blast for over 3 months.
Exactly. And then another 150 days, maybe more, just to dim down to half that brightness.
That's incredible persistence. And the brightness itself, you said very bright.
Oh, yeah. We're talking 30 to maybe 1,000 times brighter than a typical supernova.
1,000 times. Supernovas are already these incredibly powerful events.
Right. And the flares associated with these ENTs can be 2 to 10 times more energetic than even the most powerful supernovas we knew about before. So it's this really unique combination, incredibly bright and incredibly long-lasting.
Okay, that level of energy, that time scale, it really makes you wonder, how does something like that even happen? Where does this energy come from?
Yeah, that's the million-dollar question, isn't it? The leading idea right now is that ENTs come from what researchers are calling megastars.
Megastars, so not just regular stars.
No, much bigger. Think stars maybe 3 to 10 times the mass of our own sun. And these megastars get absolutely shredded by supermassive black holes.
Ah, okay, so it's related to tidal disruption events, TDEs, where a star gets ripped apart by a black hole.
Exactly, but think of ENTs as like supercharged TDEs. A typical TDE usually involves a smaller star, maybe less than twice the sun's mass.
Right, and those produce light for maybe days or months as the material heats up.
Precisely. But with ENTs, you've got these much more massive stars, 3 to 10 solar masses, being torn apart by truly colossal black holes around 250 million times the mass of our sun.
250 million, that's a monster black hole.
It is. So the whole interaction is just on a vastly more extreme scale. Way more violent, way more energetic.
It sounds incredibly violent, chaotic even, but is there a bigger picture